Check, check. I should have checked that sooner. Whoa, why do I have that bad boy up? Quit. Welcome back to YouTube. Today's 424. We haven't done a video since 4/9.
Wow.
Well, wow. I think we should have started off with the proper.
Because I guess for some reason Mr. Munoz said you could have all this time to study.
Whose fault is that?
It is, but hey, you know what? I gave you what I said I did I not?
But we still ended up with enough time.
If I say something, if it hurts.
It's not like it's like May 10th and we're like, well,
Alright, so let's get to this. Again, today we're going to be finding limits. Of course, I'll explain to you what a limit is. And then Hank here is going to be my TA.
oh my god, to make fun of him.
So we're going to take a look at tables, and we're going to do it with graphs as well. Not this. So hopefully by the end of today, I do want to make sure that that we don't move on without you understanding what these things mean, because this is going to be the basis for many of you going into calculus, and it's just going to make it that much easier. I hate to say hit the ground running, but at least you'll have an idea of what's going on, and you don't feel overwhelmed as you begin, because this is literally some of the first lessons they talk about. So we'll talk about the notation for starters. We will use some tables. We'll use some graphs, ladies. And then we'll take a look at one-sided limits. Okay? So, and these are not very difficult ideas at all. So, let's get started here. Limit notation. Oh, this is such a nice slide. So much information in it.
That's it? That's all that's on that?
Okay, so usually you'll be given a function. Okay? Let's call that function what we've always called this function. Let's call it f of x. Okay? Simple enough? This can be y equals 3x plus 2. This can be y equals x squared. This can be any function that you want it to be. It just is some function. Okay? And we will literally ask for LIM. That stands for the limit. The limit of this function as x approaches some number we call a. That's your limit notation right there.
Easy peasy.
And of course that's going to equal, we'll call that the limit value. So this will equal some number, and we'll just call it L for limit, whatever that limit is going to be.
Thank you. Thank you. Oh.
Bless
Thank you.
Okay? So this is the notation. And all that this is asking for is what number this function is getting closer to as we approach this bad boy from both ends of my function. Make sense? Not necessarily. No, it doesn't do infinity. Here, let me give you an example of what I mean by this. Okay? Just visually. Let's go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. What kind of function do you guys want? Parabola maybe?
Yeah.
X squared.
Yeah, let's do x squared. So x squared looks something like, let me try to put some decent numbers up here. Should be probably higher, right? Okay, so it kind of looks something like this. I try to put in some points. So here is, ladies and gentlemen. So here is our function x squared.
Yeah.
Okay? And we're going to look for the limit as x approaches, I don't know, pick some number please. Don't go beyond my limits here.
3.
Sounds good to me. So as x approaches 3. Now, of course, this thing kind of goes on forever, doesn't it?
Yeah.
I don't know if I can reach that high, okay?
Sorry.
Let me,
Do X approaches too.
I'll just bring it down. So here is 3 right here, correct? We're going to take a look at how this function or what value this is approaching. 1, 2, 3. And it's supposed to be getting closer to what number? What number is that?
4. I don't know.
Yeah, it's 1, 2, 3, 4. That's really what we're after. As our function is approaching this 3, this x, what are we getting for y? So as we're getting closer, this function is getting closer to the value of 4 in this direction. Value is getting closer to 4 in that direction as well. Therefore, the limit for this, as x approaches 3, would be 4. So I guess in simplest terms, You're looking for the y value as you get closer to 3. As you get into 3. Does that make sense? Now, in this case, obviously, we know that it's 4, correct? No. That's not correct.
Why
It should
is
be
it
9.
Yeah.
I was way off. It should be 9.
Okay,
So
that
it's supposed to be
makes
getting
more
closer to 9. I don't know why I thought it was a 2.
I don't know what's going
I don't know why I thought it was a 2. Yeah, that was bad. Let me do this again.
Do as X approaches 2.
Yeah, so let's change that to 2. And then it'll make more sense. So, yeah, because that was way off. Okay, so here's the 2, right? You see that that's the part of the function that I'm getting close to? This is what I want to approximate. So as I'm getting closer to here, what y value am I getting close to? 4. That's my limit. Okay? Now we know from all the algebra that we've done that it is 4, correct?
Yeah.
But that's not necessarily true all the time. Okay? Let me tell you why. Sometimes you have a function, and yeah, it is smooth and continuous. So the limit or the y value that we're getting closer to will be that one number. But that's not what we're interested in. We're interested in what we're getting close to. Sometimes you'll have functions where that value actually does not exist, because it might be an asymptote of some sort. It might be, do you guys remember that removable discontinuity business? So that's what can happen there. Or we can have something weird like this, where at that specific point only, the value is something else. Okay? So, regardless, does the limit exist here?
Yes.
Yeah. As I approach, my value would be L. Over here, even though there's a hole there, as I get closer to it, what am I approaching? L. Same thing here. As I'm approaching, I'm getting closer to L again. So for all 3 of those, the limit does exist, and the limit happens to be L. Questions on that? Does that make a little bit more sense? I jacked it up with that 3.
Dang it, you confused me.
No, I can't learn this ever.
Because I was just trying to figure out how we're supposed to plug 3 into
Okay.
that equation. I was like, that's not, I don't know.
And we know what value would be.
Yeah.
And I was still, whatever. I'm gonna move on. So here we have a question for us. Hey, you know what? We've got this function. The function happens to be 4x squared. They want to know what we're approaching as x approaches 3. So what y value are we getting closer to as we get closer and closer to 3? Okay?
36?
Yeah.
Thank you.
Yeah, it is. It's 36. And what we'll do sometimes is they'll give you the table of values. And then you'll see that, oh, they're getting closer and closer this way. Now, sometimes it won't give you table of values. This is why it's very important to have a calculator. So if you have one with you, go ahead and grab that. If you don't, then just watch.
Oh. No, I can get this because I don't know how to use this thing. Hold on. He says stuff and it's like, what? Like, where do I push that in? Like, I don't. Like the problem yesterday on the test with the infinity. I tried. What did you do? I know, and I tried them. I'm sure I got it. Whatever.
I'm using Wabbit emoji.
Why is this still there? Go away.
Is the reshape review up for chapter 10?
Hold on. Let's do this.
Sorry, it was just in my head and I wanted to ask you. I read it on the board.
Wait, go back.
Go back to what?
Y equals.
I just put 4x squared in there.
That's the biggest fan of watermelon.
I love apple. But ever since recently, I've
It's my apple.
eaten it and then like my mouth got
I think if anything, I need to do my if Val's coming, as long as
It's why your tongue feels weird. Yeah. So is it normal?
yeah.
I was like, I'm just gonna say that I got yourself. If I accidentally got one, I got a pin. I got a pin. Yeah. Pin. The screw fell out. I got the lens popped out. So I'm gonna go get it fixed up. But it only takes 5 minutes to have it.
I need to go get my pencil. I think, well, I know.
Okay.
I skipped everything.
So everyone got 4x squared in there?
Yes.
Now, I could take a look at the table of values. And I just went second table.
Oh no, I accidentally pressed.
Oh, I should have gone, let me go to table set. Let's go to like,
Wait, how'd you do that?
Second, and then it's was it step? No, it was second, and then like the second. Oh, graph.
oh, now I went too far.
It wasn't graph, it was.
Think that'll work? That'll be good? No. Let's go 2.9. Jesus Christ.
Watch your profile.
Oh, sorry.
Here you go.
I did that around Mr. Shapiro one time. He's like, name dropper.
What is going on?
Okay, here we go. That's what I want to see. Okay, so imagine that this is part of the graph. These are all my x values. Yeah, they're changing by 0.01. So notice that this is getting closer and closer to what value? 3. It's getting closer, closer, closer to 3 on one end. Closer, closer, closer to 3 coming from the other end. What y value are we getting closer, closer, closer to? 36. Now, we know that it's going to be 36. Okay? But we don't care about what it equals. We care about what it's approaching. And that's the big idea of the limit. It's what we're approaching. Not necessarily what it is equal to, what we are approaching.
So, will the answer 36?
We are approaching 36.
So, like, oh, it's 36.
We don't care about what it equals, we care about what it's approaching. Okay?
What is it a case where it doesn't equal what is approaching?
Oh, we're singing for it?
Did I not show you that right now? Remember when we used to have rational equations and something in the numerator would cancel with the denominator?
Oh,
That's removable discontinuity. That would be an example of having like a little hole in there. Or like you're not equal to that, but I could kind of just put a open circle in there, remember?
What's it called when they've got like the little bracket right there and it's got two different equations for one x?
Piecewise.
Piecewise.
Piecewise as well. And we'll have some of those where they don't, where they don't match up.
I'm just gonna wait to ask questions because
Why? No, ask
no,
now.
like I got it. I'm just confused how we're gonna get there.
So, let me try to make this a little bit bigger. Now let's try to find limits looking at the graph. Here's our first question. And here's the function. They just called it f of x because it's blah, right? They want to know what the function is approaching as x gets closer to -2. So here's my -2. Here's my -2. I'm going to see what I'm getting closer and closer to in this direction. And I also want to see what I'm getting closer, closer, closer to in this direction. And as you can both all see, we're getting closer to 5. That's it.
So are we only gonna be using graphs, or are we gonna be given equations and stuff?
Well, right now, what's our objective? Can I find a limit from a table or a graph?
That's 11 point.
Okay.
This is our first section. We're not going to jump into that later.
Okay.
We'll jump into that later. Okay?
Sadly.
Now, what does f of -2 actually equal?
3.
It actually equals 3. If we go to f of -2, the value is actually 3. Is that the limit? No.
Wait, why?
Because that's what the graph is telling me.
Oh.
On the X, it's
You see that? Here's -2. I have an open circle. I'm not equal to that. The value is actually 3. That's not my limit. That's what it actually equal to. So again, in the limit, I only care about what I'm approaching.
Why is it different? Are they two different functions?
No. It's one function.
But the 9 doesn't even hit 3.
No, but there's a point right there.
Oh, I didn't see the point.
There it is right there.
I actually outlined it.
Okay.
I have to look again.
What is the limit?
Continuous and differential.
Thank you. So, question. What is the limit as x approaches
7.
2, positive 2?
6.
The limit is 6.
Oh.
What is What is the limit as x approaches 4?
Wait.
7.
7. What is f of 4?
2.
Wait, what about like,
Can
what
you
about
explain is that 2?
the limit of like, I'm trying to like, what about 5? Is it like 7.5?
Okay,
Oh yeah.
there's a lot of questions, and I can't hear any of them. So let's start with, no, how about we, nah, go ahead.
Oh, what about like for 5? Is it like 7.5 or do you go like
What's your
7
question?
or 8? What is the limit as x approaches 5?
As x approaches 5, so this becomes a 5, so now I want to take a look at the value here. What am I getting closer to? It looks like 7.5 maybe?
So we can use like decimals and stuff?
Yeah.
Oh, I thought we were doing a whole number thing.
I did for some of them, but you know, it doesn't have to be, okay?
So what is the limit when it approaches 4?
So as we're approaching 4, the limit, or what we're getting closer to, is this value right there, correct? Which happens to be 7.
So why isn't it when we're approaching -2?
We're gonna get these questions out because these are the baby examples.
No, I'm just confused on why the point's all the way in Egypt. Like, why is it, that's just.
I understand what you're saying.
It's what the.
Let me repeat one more time. There will be times when we get rational functions. That means there's a numerator and a denominator. And with those types of problems, you're gonna have what's called removable discontinuity, correct? Not asymptotes, not where it goes, bleh. We'll have specific points where the function doesn't work there. But for some reason, we find that, hey, you know what? At this point, 2 does work for it, and we're okay with it. And what we're doing right now, we're just giving you the graph of what that could be. Okay? But right now, the biggest thing is understanding the difference between the limit and the actual value. Okay? Go ahead.
When you're approaching -2.
When we are approaching -2. So as we're approaching -2, right here,
Yes.
what about it?
What's the limit?
The limit, we're approaching 2, right? You see that? The value happens to be 5. So, there it is. Go ahead. I can't hear you. Welcome back to class. That's the graph, and that's where the function is defined. So, these open circles means that when I'm here, this doesn't exist there. There's no value there. The value actually happens to be 3. 3 will make this function work at this point. Over here, there's another open circle. That means there's no value there. It turns out that 2 makes the function work. And that's why those points are there. So this is what you're looking at, is the entire function of whatever the heck it is. It's called f of x. It could be something really funky. It could be rational. It might be rational. It might be a rational that has a denominator. So it's like a fraction in a fraction inception. So that's what you can probably get out of that. Okay? What's up?
So is the actual value for, like, let's say, what, 2? So is the actual value for 2, because the limit for 2 would be 6, right?
Correct?
So is the actual value 6 as well? Because
Yes. So the limit as it approaches 2 would be 6. F of 2 is also 6. They can be the same.
It's just because it doesn't have
Doesn't have to be.
It's
They
just
can be
because-
the same. They don't have to be. Okay? Questions? More questions?
Okay, what if you had like a big segment? Can I draw it? Can I ask it? Okay. What if you had like what if you had like your graph went to like here and then it was an open circle?
Go ahead.
How do you erase it?
With the eraser?
Oh, okay. Okay, so like what if we went here and then you had
Put down the eraser.
and then you had like a big segment down here and then this wasn't there and then it like came back here. So where would the
Okay,
limit
so, man, I want to redraw your example and then tell me if I'm wrong, okay? So let's say we had, oh, I should use a different color. So she's saying, hey, you know what? I've got something that does this, and then I've got a piece like this,
Yeah.
and then it kind of carries on
Yeah.
over to Neverland,
Yeah.
okay? We'll get to those. But since your question is there, we can still talk about it, okay? Now let's say that this happens to be -1 right here. Okay? And then we'll call this piece 2. Okay? So that means we'll put a -2 here. Let's try to put some values. Let's call this piece 1. And then we'll go 2. Does that work? Does that work for everybody? Okay? So let's ask. We have some function here, right? I don't know what it is. Obviously, it's going to be piecewise. Why is it piecewise? It's broken up, right? So this is probably one function, this is another function. Maybe I go back to the function, or maybe it's a totally different function altogether. Okay? So I'm going to ask for the limit as x approaches -1. Okay? As I'm approaching -1 from this side, it looks like I'm kind of getting closer to, I don't know, let's call that 2.5. Okay? But on this side, I'm getting closer and closer to -1. Are those the same number that my function is approaching?
No.
The limit does not exist.
Oh, okay.
I wish I could have recorded that
Does it
to
have-
mount it on here.
Does it have like
Because they're going in different directions, they're not approaching the same value, the limit does not exist. Just like if I asked you for the limit as the function approaches 2, I'm approaching -1 here. Over here looks I'm approaching maybe 3 or 4, right? That is not the same number, therefore the limit does not exist here. If I was asking for 1, well, they both seem to be approaching 1. So if I ask for the limit as my function is approaching 1, then yes, I'm getting closer and closer to 1 still.
Okay. Does like the second segment have to be a certain size?
No. They could be as funky as they need to be.
Okay, so if you have like 2 points down there instead of like the 4 of them, that's still where you start from?
You always want to approach that specific value.
Okay.
Okay?
Yeah.
Are there questions on limit still?
So for that one, because it was kind of those like different segments and had to and we're -1 degree, that's why the limit doesn't exist.
Hold on, I can't hear. Go ahead.
So that's why the limit doesn't exist, because it has two, not answers, but it has two.
I'm approaching 2 very different directions from the left and the right. On the left, I'm approaching 2.5. On the right, I'm approaching 1. Those are not the same value.
Right.
The limit does not exist. Now that's very different. Notice that this was, let me write this a little bit bigger.
What the heck?
I meant to do that. That was the notation, correct? As it approaches some value A. You will also have what's called right-handed and left-handed limits. Okay? And here's the only difference. You'll see a little negative up top. That means that what is the limit as I approach this value from the negative side? So if I said, what is the limit as x approaches, I don't know, let's go -1 from the negative side of my function. Well, as I'm approaching from the negative side, what did we say we were approaching? 2.5. But from the right side, let's go plus, from the right side, I'm approaching 1.
Oh.
Okay? And those are okay. Because that's the limit I'm approaching from the left side or from the right side, depending on what that sign is telling me right up here. It can be positive or it can be negative. It doesn't mean take -1 to a -1. It means as you approach from the negative side or as you approach from the positive side. Okay?
Okay.
So now you really got 3 things going on, right?
Yeah.
There's the value. They both have to approach from the same position. The same position from both sides. I could care about the left side. I can care about the right side. Okay? And that's what your left side limit is a negative. Your right side is a positive. You guys see that okay?
Yeah.
Okay. Questions?
Thank you.
Let's make a wish now. A wish. I didn't hear about my either until last year. And then he was just like, yeah.
So let me ask you this question then. What if my right-sided limit, my left-sided limit is different from my right-sided limit?
The limit doesn't exist.
Easy enough.
Oh wait, can I write that down?
There's your butchered Mean Girls. It's not even that funny anymore, right? Like, really?
Every time somebody says that, I think of the scene of it. Like I gotta remember it in my head.
I've only seen these movies one time.
Why don't I have the slide? I missed the slide! Why don't I have the slide?
It's 4 o'clock. What? Escalera behind me is probably one of those.
I'm gonna have to try to sketch this.
You can do it. Okay.
No.
Yeah.
Go back. Oh, Lorraine.
What color's your dress? I'll show you. Yes, red. No.
Way back. I can change it now?
I mean, it's not too bad because hers.
Okay, I'm gonna have to try to draw this here.
Because the gold earrings is like but mine is more soft. Are you getting it? I always she still wants that dress too, which is funny. She's like, yeah, I tried it on, and I told her someone else. She's like, wasn't it? I should have told her.
Knee slapper.
Yeah.
You know what I like? I like the Joe. I like the Joe.
See that okay? Garrett, can you see that okay from back there? Yeah. Better?
Oh wow. Go Mundo.
Okay. Thank you. What is the limit of this function
No, it doesn't have one.
as, whoa, commentate.
Okay. It doesn't there's an option like the limit doesn't exist.
Find that for me first. Go.
0.
Quiet it down. Let's let everybody have a chance. Please find that for me first.
I don't
0.
What? Oh, I get it. I get it. I get it.
Good. Good. Okay, so once you have that, I want you to find me the limit to that. And finally,
Why is this week one so slow?
I don't know.
See, this is the thing is I don't get it. That last one, the last one.
Okay, so for the top one, what is the limit as x approaches 0 from the left side?
2.
The answer is 2. Check your work, check your notes. What is the limit of the function as x approaches 0 from the right side?
1.
It is 1. Last question. What is the limit at x approaches 0?
The limit
It doesn't exist.
It does not exist. That's because they don't approach the same number. In order for this to exist, the limit from the negative side should approach the same limit as from the positive side. Okay? They gotta be the same. And they're not. Therefore, it does not exist. Okay? You guys good?
What if they're like 0.01 units away?
Doesn't matter. As long as it approaches the same thing, okay?
It's like,
Okay. Here's your next question. This was the most important slide I wanted, and I didn't put it up there.
Wait.
No.
Oh.
Wrong. So I think, are we looking at that or the, or no? And then the last one?
Oh, I know.
Yeah, why are you looking at that?
No. But
That's two.
No.
Same thing.
Yeah, I know.
Okay, wait.
I'm gonna add another one.
I see what you're saying. I thought we were doing.
Add another question there. So you got 4 questions up there.
Which one, who is, where, which one is the middle?
Oh, sorry, I should. That's not the question I wanted at all. Sorry.
Oh, yeah, it is.
I just looked at over there like, oh, that's not the number I wanted. Campbell.
18 years to grow the boobs that I did.
What is the limit of this function as x approaches -1 from the negative side?
I don't know. I don't know if it exists or not. If it does exist, it's 0.
If it doesn't, then it doesn't.
Oh, that's cool. 22 is.
I don't get. Okay, wait.
Okay, so let me follow my function from the negative side, right? And I'm gonna care when I get to right here.
Oh.
Because that is -1, right?
Yeah.
So none of this matters to me. There's some funky business going on here, I don't care. Here we go. I'm approaching from the negative side. What am I getting closer to?
0.
0.
Okay, so we're right. Okay.
Oh,
Whoa.
okay. Now, let's approach from the positive side. Campbell,
Yeah.
what is my limit
0.
as x approaches -1 from the, it is 0, right? Now I'm coming this way, I'm approaching -1.
It's 0.
Now, what is the limit as x approaches -1? It is 0, because they're approaching the same value on the left and the right here.
-1.
Question, what is f of -1?
0.
It is also 0. Okay. Questions?
Yeah, I was always
That don't matter, that's not even, that stops right here at 0. So I'm gonna go to the blue one now, and I'm gonna approach -1 from that side, and I'm approaching 0. Okay? Slow like molasses. Okay.
There's more math.
Dallas,
Oh, I'll go watch it.
Yahtzee,
Oh my god. No,
answer these 4
the one
please.
that I was confused on.
Okay,
The last 0.
It's 0.
But
The limit is 0. Yes, the limit is 0, but it doesn't equal 0. No,
sure that we have enough time for your writing finals. And
We had no negative.
Bro,
Sure, it's gonna get end with a C this semester.
wait.
Maybe that's why I don't have to.
Oh.
Hey, are we done?
Are we done?
I have a question.
you have a question?
I wish
About
this
the
was
finals.
Let's finish this first, and then we'll hit. Okay?
I forgot we had to make finals.
Hold on, we got some people that.
I'm just texting my mom. And,
I said, I hate this job, but I played transfer, and they said, yeah. Yeah.
So that's
Because I'm still trying to like, really good Starbucks because they're nice and workers. We're just like working at extra. So it's really easy to just transfer.
This goes from positive.
yeah, I was thinking about this.
Very hard. I can make you shadow raspberry. I can make you shadow.
Let's go like the turkey. Does that mean it's not?
Oh my God.
Doesn't have one or?
When?
Is there a question?
It's so Friday, 8:30.
I wanna know now.
Oh, sorry. That was kind of
I work 3 to 8:30 on Thursday.
That's a good one.
7 to 3 on Saturday. I don't know.
You like my stripes?
Hey, those are nice.
Okay, thank you. Question is, what is the limit of this function as x approaches -2 from the left side?
Me?
Yeah. 0.
He's wondering. The answer is 0 now? It's 0. It has to be 0.
Why 0?
No, it's not even.
That's my job. How'd you come up with 0?
because it's going to the left side, so the only one going to negative 2 is that line, so.
What 0? The y value that I'm approaching is 0? Good. What is the limit of this function as x is approaching -2 from the positive side?
That circle's almost perfect.
97.
It was.
That's true. That's so perfect.
Campbell. I'm approaching -2 from the positive side. Okay, so this is my limit line right here, right? This is what I'm approaching? Correct? So what y value am I getting closer to as I get closer to that line? What is it, Campbell? What is my limit as x approaches 2? Because these are not the same, this does not exist.
What's this?
But f of x.
But what's f of -2?
We got this.
Whoa.
Yeah. What's the value of x, or sorry, of y when we have that? Oh, here's a solid circle right there that represents -1.
Oh, we're doing this now.
So there you are. So there's all of the things going on. Questions?
Is that it?
That's all I got for today, yeah.
Today? I can do that. Yeah, me too.
Me too.
Slowly, but I'm just gonna stop